Today we will learn to simplify radicals with real and imaginary numbers, but without variables. We know how to simplify the square root of 64, it's 8, and the square root of 36, it's 6, and even the square root of 144, it's 12. But what about the square root of 68? It's not a perfect square, so we can't just take the square root of it. Now, you'll need to know perfect squares up to 144 for my class. Perfect squares are numbers that are products of two of the same number, such as 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Below are the numbers that you will need to memorize as perfect squares for this class. Now back to the square root of 68. In order to simplify radicals that do not have perfect squares, you must take these steps. First, you find the largest perfect square that divides the number. Then, write the factors, put a square around the perfect square, write the square root of the number in the square outside of the radical, put the number left over inside of the radical, and check to see if there's another perfect square that can come out of the radical. If there is, you must repeat this process. Now, back to our square root of 68. You find the largest perfect square that divides this number. That would be 4. So the factors are 4 and 17. You put a square around the perfect square. You take the square root of that number that's in the square, so the square root of 4 is 2. You write it on the outside of the radical and take the number left over, 17, and put it inside the radical. Now finally, we check to see, is there another perfect square that can come out of the radical? Well, there's no other perfect square that'll divide 17, so this one's complete. Let's try another example. The square root of 72. Well, 9 times 8 is 72, so 9's our perfect square. We put a square around it. We write the square root of the number in the square outside of the radical, that's 3, and put the 8 under the radical. Now, check to see if there's another perfect square that can come out of the radical. In this case, there is. That number would be 4. So we repeat the process. We put a square around the 4, take the square root of 4, which is 2. Now you have to multiply that number by what's already outside. So that 2 times 3 is 6, and then the 2 that was another factor gets back under the radical. There's no other perfect square that will divide 2, so we're complete with this problem. Now, had we done it correctly the first time, we wouldn't have split it into 9 times 8, because the largest perfect square that divides 72 is actually 36. So we would have put a square around that number, taken the square root of 36, which is 6, put it on the outside, and put the 2 under the radical. 6 square root of 2. Either way, we get the same answer. It's just a lot faster if you find the largest perfect square first. Let's do another one. Let's do the square root of 40. The largest perfect square that divides 40 is 4. So we get 4 times 10. We put a square around the 4, take the square root of the 4, which is 2, and we've got 2 square root of 10. We check to see if another perfect square can come out of that radical. 2 times 5, neither of those numbers are perfect squares, so we have completed this process. Let's try the square root of negative 27. Wait, you can't take the square root of a negative number. So there's this nifty little thing called I. I represents the square root of negative 1. So what we do is we take that negative out of the square root by putting an I outside of the square root. So now it's going to look like I square root of 27. So that got rid of our negative by factoring out the negative 1. So again, we're going to write the factors and put a square around the perfect square. 9 times 3 is 27. The perfect square is 9. So we put a square around it. We take the square root of 9, which is 3. And it goes on the outside, but we got to keep the I. So it's 3i square root of 3. We check to see if there's another perfect square that can come out of the radical. There's not. So we don't have to repeat the process, and we are done. So again, in order to simplify radicals that do not have a perfect square, you take these steps. If there's a negative number under the square root, take it out and put the I, because the square root of -1 is equal to I. Find the largest perfect square that divides the number, write the factors, put a square around the perfect square, write the square root of the number in the square outside of the radical, put the number left over inside the radical, and check to see if there is another perfect square that can come out of the radical. If there is, you must repeat the process. If you have questions, bring them to class. Make sure you complete the completion form.